PhET Interactive Simulations is a wonderful resource to help students at all grade levels visualize and understand abstract mathematical and scientific concepts. The URL for the resource is phet.colorado.edu. The free simulations developed by the University of Colorado can be downloaded onto a PC or Mac computer or viewed online on iPads, Chromebooks, and tablets, since most simulations were converted to HTML5 format. The simulations are organized by subject area: physics, chemistry, biology, earth science, and math, by grade level, elementary school, middle school, high school, and university, and by device. The simulations are designed so that students can work on them independently, with a group, or as a class. Let's explore a simulation designed for elementary school. The simulations are in alphabetical order by grade level. The red 5 icon in the lower right-hand corner indicates that the sim is in HTML5 format and can be used on any device. Let's examine the balloons and static electricity sim more closely. Notice that the simulation can be downloaded, viewed online, or embedded into programs like PowerPoint. Included with each sims are topics covered, a description, learning objectives, and teaching tips. The new HTML5 sims includes a video primer which provides guidelines for using the activity as well as suggestions for implementation in the classroom. The accompanying PDF for all sims provide detailed instructions for the activities. Teachers can access teacher-submitted activities that contain suggested lessons, questions, and answers. Let's click on the balloon and static electricity sim. The objective of the sim is to help students visualize charge transfer and polarization. Notice that we are given the option to show all charges, no charges, or charge differences. Here we see that the sweater, balloon, and wall have equal numbers of positive and negative charges, indicating that everything displayed on the screen is neutral. We will now grab the balloon and rub it on the sweater. Notice how the negative charges are transferred to the balloon and that the positive charges remain fixed on the sweater. The balloon is now attracted to the sweater. Let's see what happens when the balloon approaches the wall. Notice how the negative and positive charges are polarized. The negative charges are repelled by the presence of the balloon. Now let's explore another simulation designed for older students in a specific subject area like chemistry. The Build an Atom sim is a great example that contains 3 activities which can be played independent of each other. Notice that the sim has a video primer as well as the detailed instructions in PDF format. The objective of the atom activity is to build atoms and to determine its identity, net charge, and atomic mass. Notice that you are given a choice to display the element name, neutral versus ionic, and stable versus unstable. You also have the choice of an orbital or cloud model. As a quick demo, I will build a lithium atom. Notice that I can only add particles to the proper place within the atom. Protons and neutrons must be placed in the nucleus and electrons in their orbit. We can now examine the net charge and the mass number. To access the next activity, click on the icon at the bottom of the screen. The objective of the symbol activity is to interpret atomic symbols by building atoms using protons, neutrons, and electrons. When students add protons, neutrons, and electrons, they can see the effect it has on the actual symbol. Finally, let us access the game activity. Notice there are several types of games that can be played. The game can be timed and the sound can be turned off. Here's a quick demonstration of the first option. I have enjoyed exploring these sims and have used the Trig Tour in my Common Core Algebra 2 class. I hope that this video encourages you and your students to explore this wonderful resource.